This video is for Math 70, and this is the second assignment on word problems. And there are two types of word problems, well, either like this or like this. Two types of word problems on this handout. One is mixture problems, and the other one has to do with different rates. So the first type, mixture problems, are very common, and you see them frequently. A lot of the problems on this handout have to do with mixtures of nuts. Looks like there's one with gasoline in there. A lot of times the applications are in chemistry, mixing strength, how strong an acid solution might be. Places where I've seen this in real life, I had a student, a Math 70 student, I don't know, 10, 12 years ago or something, who worked for medics. And they have these bags of saline that they carry around with them in the truck, I suppose, and they are different concentrations of saline solution. And to get the right concentration, you can take the one that you have and mix it with something else and get the concentration that you need. So there is one application of these types of mixture problems. Another situation was, this was before I started working here. I was I was actually at a high school reunion. I was talking with a friend of mine and his wife. And his wife worked at this commercial bakery where they made very large batches of dough that would then be shipped out to supermarkets. You know, when you buy bread, that fresh baked bread at the supermarket, frequently that dough is made someplace else and then it's shipped as dough to the supermarket and baked at the supermarket. So the business who mixes that dough, they end up with leftover dough at the end. You know, when you empty out whatever it is that they're mixing it in, there's some left over. And rather than throw that away, she was asking me about how can I use that to make a different kind of bread. Because a different kind of bread, now, this is, like I said, this was years ago, and I can't remember exactly what it is. It's like, I think it's yeast and water. There's like different percentages of yeast and water that have to go into the bread. And so that make different kinds of breads. And so if you increase the amount of water in one recipe, then you can make a different kind of bread. Or if you increase or decrease the amount of yeast. And so she was asking me, how can I do that? And that's just it's a mixture problem, straight ahead mixture problems. So I just want to communicate to you that these issues come up frequently in a lot of different situations. And so something I like to say about mathematics is that, people who bake bread and people who work as EMTs have very different jobs. But the mathematics is what's the same. Okay? And that's, something I always say that to the pre-calculus class when we're looking at the shape of a satellite dish, the shape of the flashlight beam or a headlight beam are the same shape, and people who make those work in different industries and they have very different concerns, but the mathematics is what's the same about them. Okay? Alright, well let's look at some mixture problems. Before I start this, I want to talk about something that wasn't on that introductory assignment. Okay? If you have a length, you can say it's a length of board or whatever it is. Let's say, let's say it's an 8-foot 2x4 or something, okay? If we want to split this in two pieces, if we call one piece x, now we don't want to introduce another variable. We could just call this y, right? And then we could say x plus y has to add up to 8, okay? That seems pretty straightforward. But introducing a second variable creates more complications than sometimes we really want in a problem. Sometimes it's unavoidable, but sometimes it is avoidable, and this is one of those situations. See, if I move the x just like we did in the for substitution, right? To solve a system of equations by substitution, we isolate one of the variables. This y is actually nothing more than 8 minus x, okay? So you can, when we're going through these problems, I'll talk about it in both ways, okay? Sometimes we'll have a separate equation that relate x and y, and then we get one of them by itself. Sometimes we can just bypass this and use that, okay? So what I'm saying is that if you have a total of something and you split it into two pieces and one piece is x, the other one's going to be the total minus x. And we'll see that repeatedly in these mixture problems. Okay, so let's look at one of these. Problem 2 says a bake shop has cookies worth $2.70 a pound. Okay, and cookies worth $4.50 a pound. Okay. How many pounds of each kind should the manager use in order to have 100 pounds of cookies to sell at $3.75 per pound? Okay. Now notice that this $3.75 is in between the two prices. So the idea is we're going to mix them together. If we use equal amounts, then the cost will be exactly halfway between it. Okay? So let me figure this out just for illustrative purposes. So if we take 270 and 450 and average them together, we get $3.60 a pound. Okay? So if you use 10 pounds of each, then we would want to charge $3.60 per pound. If you use 20 pounds of each, same price, all right? As long as the amounts are equal, then you're going to be charging $3.60 a pound, okay? Now, if you have more of the expensive one, you're going to be charging more than $3.60 a pound. If you have more of the cheaper ones, you're going to be charging less than $3.60 a pound, okay? Now, exactly where that happens is what we're going to solve for, okay? Exactly how much more of the expensive one is going to produce a price of $3.75. That's the equation that we're going to write, okay? All right, so I mentioned we can do this two different ways, okay? One way is to say, let's call the number of pounds for this one x, and the number of pounds for this one is y, and then we know that x plus y is going to have to add up to give us 120 pounds of cookies, okay? Now, when it comes to the cost, right, if you take the number of pounds times the price per pound, then that'll be the cost of these cookies. So we'll have 270 times x, and then take the number of pounds here times the cost per pound, that'll be 450y, and that should add up to $3.75 per pound times 120 pounds. Okay, so that's the total cost for this mixture of cookies. It's going to come from the cost of these plus the cost of these. All right? Okay, now, the other way of doing this is just to skip past the x plus y equals 120 right to y equals 120 minus x. Right? You see we've got a total of 120 pounds of cookies. If you call this one x, this one will be 120 minus x. Okay? So whether we skip past that or not, we're going to take this 120 minus x and plug that in for y. So let's see here. 270x plus 450 times 120 minus x equals 375 times 120. So there's our setup, okay? Remember, this is coming from the cost of the cookies. The total cost for this 120 pounds is 375 times 120, And that cost is just coming from the two different types of cookies. The number of pounds of that one times the cost per pound, number of pounds of this one times the cost per pound for that one. All right, let's see here. Let's make some room. So now we're going to have 270x, 450 times 120 minus x is going to be 375 times 120. So let's get the calculator out here. And so this will be 375 times 120 is going to be 450. This will stay 270x. 450 times 120 is 540 minus 450x. Okay, so now we want to combine our like terms. We've got a minus 450 and a positive 270. Is that 180? Yeah. Negative 1.80x plus 540 equals 450. Move the 540 to the other side. 450 minus 540 should be negative 90. And then we divide on both sides by negative 180. 1.80. So 90 divided by 1.8 is 50 pounds. So 50 pounds of the $2.70 per pound, and that means the Y will be 70 pounds of the more expensive cookies. And that's what we said to begin with, right? If this price is higher than $3.60 a pound, that's because we used more of the expensive cookies. Okay, so there's that first example for these mixture problems. Let's keep moving with these. Let's look at number 4. Okay, problem 4. How many grams of spice worth $4.20 per gram must be mixed with 30 grams of spice worth $3.60 per gram in order to produce a mixture to sell for $4 per gram? Now this problem's a little bit different. I'll talk about that more in one sec. So first off, we've got some spice that's going to cost $4.20 per gram. And then the other spice, we're going to have 30 grams, and it costs $3.60 per gram. So this one we could call X. This one we don't need a variable. We know how much we have. We've got 30 grams of it. Okay? In the end, we're going to sell the mixture for $4 per gram. But the question is, how much of it are we going to have? We're going to have X plus 30 grams. Okay? So it's a similar format, but the way the question has been asked is a little bit different. Okay? But we're still going to set up our equation the same way, right? Because this cost, you can see this cost is closer to the more expensive spice, and so X is probably going to turn out to be more than 30. At least it should. All right. So our equation, to get us started, is the number of grams of spice times the price per gram, 4.20 times X, plus the number of grams of spice times the price per gram. That's the total cost, and then here is another expression for the total cost. Number of grams of spice times the price per gram. Okay? So, it's just, that's why these two things are equal, is that this is one representation of the total cost. This is another way of representing the total cost by breaking it down into the cost for each type of spice. Okay, so now that we know that, we've got 4.20x, 30 times 360, let's see, is that going to be 108? It's going to be something along, I may have got my decimal point, no, because 3 times that would be $10.80, 30 times 3.6, 108. Okay, so over on here, we've got 4x plus 120. Okay, so I'm going to subtract the 4x over here. So this is 4.00, so we come out of this with 0.20x plus 108 is 120. So let's move the 108 over here. 0.20x equals 12, right? So then we divide on both sides by 0.20, and x equals 60. And remember I said it was going to be more than this 30 grams. In this case, it's twice as much. Okay, and let's see, did we answer the question? How many grams of that spice do we need? 60 grams. Okay. All right, let's see here. Let's look at problem 8. Problem 8. Raisins selling for $3.85 a pound. Okay, mixed with nuts. Let's sell for $6.25 per pound. To make a trail mix that we want to sell for $5 per pound. Okay. And how many ounces of nuts will be in 3 pounds of the trail mix? Okay, well, we've gotten a little bit fishy here. First off, we need to know that there's 16 ounces in each pound. Okay, so when they're talking about 3 pounds, I'm going to set this up as 48 ounces. We could keep it as, let's keep it as pounds. I'll go back and do it this way in a minute. But let's just keep it as pounds, okay? At the end, we can translate into ounces. But so we want, let's see here, 3 pounds of trail mix at $5 a pound. Okay, so again, if this is x, then this one will be 3 minus x. And you can call it y if you'd like. But in the end, it's going to be 3 minus x. So if you did call it y, okay, then we just know that x plus y will equal 3. Okay? Now, the really important equation is the one that equates the cost of these things. The raisins and nuts separately and the trail mix mixed together. Okay? So the raisins and nuts separately is going to be 385 times x plus $6.25. Now you can use y here, but eventually we're going to replace that y with 3 minus x anyway. Okay? So I'm just going to put the 3 minus x in there, and that should be equal to 3 pounds at $5 a pound. So that's just going to be 15 on that side. Let's see here. Over here, we're going to have 3.85x plus 625 times 3, that looks like 1875, minus 6.25x. Okay, so now, because they're on the same side, right, my x's are on the same side, and so I just calculate with them. 3.85x minus 6.25x equals negative 2.40x. Okay, plus 1875 equals 15. And let's see, that should be, if we subtract 1875 on both sides, those will cancel out. We'll get negative 240x, and it should be negative 375, right? Yeah, got negative 2.40x is negative 3.75. So divide on both sides by negative 2.40. And what do we get? 375 divided by 240. Oh, 1.5625. Okay. Well, so that's why the question was asked in ounces. Okay. So if x is 1.5625, if we do 3 minus that, then y is going to be 1.4375. These are in pounds. Okay. And let's see here. Let's see. I always like to find the average here, 3.85 plus 6.25 divided by 2, so 505. So if we used equal amounts of each, the cost would be $5.05 per pound. So this is just a little bit cheaper. That means we're going to need a little bit more of the raisins. And that's what we did get. 1.5625 versus 1.4375. Now, to translate this into ounces, multiply this by 16. So 1.5625 times 16. So this is 25 ounces, and 1.4375 times 16 is going to be 23 ounces, and that makes 3 pounds. That makes the 48 ounces that I was talking about to begin with. Okay? So we could have done this problem in ounces to get started with. The only thing that would have been different is that this would have been 48. Well, I say that now, but these prices are all per pound. Okay? So I hesitate to move away from using the pounds when we've got these prices per pound. I think there's definitely a way around that. I wouldn't worry about it too much, but I always hesitate to change a problem too much without really, adjusting the pieces to make it fit. So I think that this is a good way to do this, to solve it with pounds, because that's what we were given the prices for. And then at the very end, just multiply by 16, and that'll turn these into ounces. Okay, so that's problem 8. Let's see what else we've got here. Okay, problem 10, we've got more nut mixtures. Let's see what that one looks like. Okay, Brazil nuts at $5.80 per kilo. So Brazil nuts, $5.80 per kilogram. And walnuts at $5. Walnuts at $5 per kilo. We'll use that as an abbreviation. Okay, how many kilos of each kind of nut should be included in a 40 kilogram mixture that costs $5.50 per kilo? Okay. Well, it looks like this is closer to the Brazil nuts, so we're probably going to be using more Brazil nuts, just as an, sort of a way to see where the problem is headed, and just as a quick check when we do get our answer. Okay, so we can set this up as x and y if we want to. If we do that, then x and y should add up to 40. Okay, and then if we subtract x on both sides, we can make the substitution y equals 40 minus x. Okay, so this is the next step is the big step, is setting up this equation. So we've got the cost per kilogram, the number of kilograms times the cost per kilogram. So 5.80 times x plus $5 times 40 minus x. Has to be equal to 40 times 550. Okay. Let's see here. All right, so we've got to make some calculations here. 580x will stay the same. 5 times 40 is 200 minus 5x, and then we got to do 40 times 550, 220. There we go. Okay, 580 minus 5.00 is going to be 0.80x. We don't really need the 0, but I'll put it in there. Plus 200 equals 220. Subtract the 200 on both sides. And then divide on both sides by 0.8. And x is going to be equal to, looks like 25. So, if the x is 25 kilos, then this one will be 15 kilos. And that's what I said at the beginning, right? Because this price is more than the average. The average of these two would be $5.40. We're going to need more of the more expensive kind to make that happen. Okay, so I think I'll stop there on this first group of problems, on the mixture problems. And then we'll take a look at these rate differential problems. So these have to do with filling something with water using water that's coming in at two different rates. Okay? And so this is a little bit of a mixture problem, but really all you're mixing together is the water that's coming in at two different rates. So here's the standard scenario. Problem 2 in this set of problems, we've got a 6,000 gallon water tank. Okay? Two different spigots are used to fill it. One that produces 300 gallons of water per hour. So there's one at 300 gallons per hour. And one that produces 220 gallons per hour. Okay. If the sum of the running times for both spigots is 25 hours, so together they ran for 25 hours, how long did each spigot run? Okay. So we'll say, let's say this one ran for X hours, and this one ran for Y hours. And that tells us that X plus Y has to be 25. Okay, so there's the start. Next is the big equation that is going to give us the solution that we're looking for. So 220 gallons per hour. If it runs for Y hours, then we'll get 220 times Y gallons, right? For 1 hour, it'll be 220. 2 hours, it'll be 440. 3 hours, it'll be 660, and so on. All right? Same thing with this one. It'll be 300 gallons times the number of hours. And that, they tell us, has filled the tank, which is 6,000 gallons. So those two things added together have to make the 6,000 gallons. Right here, subtract X on both sides. Y is 25 minus X. And like I said, you can skip that step and just go right to this. If you know that they're going to add up to be 25, this can be X, this can be 25 minus X. However you want to approach it. Now we've got to make that substitution. 220 times 25 minus X plus 300X equals 6,000. So 220 times 25, 550? Oh, 5550. 220 times 25, yeah, 5,500. minus 220x plus 300x equals 6,000. So this will be positive 80x right here, right? Positive 300x, negative 220x. That gives us positive 80x. Subtract the 5,500 on both sides. 80x is going to give us 500. So 500 divided by 80, 6 1/4, 6.25. And the other one, 25 minus that, 18.75. Yeah. Okay, so that's the 220 gallons per hour, and this one is the 300 gallons per hour. And there we go. Okay. Let's look at a couple more of these. They're going to follow the similar format. And you can see it has some relationship to those mixture problems. All right, you're adding these together to get the total. Then you've got these two different expressions for the same thing on either sides of the equal sign. All right, problem 4. This tank is 5,850 gallons. And we're going to fill it, one at 150 gallons per hour, and the other one 80 gallons per hour. The sum of the running times is 60 hours. So, we know that x plus y has to be 60, right? If this one runs for x hours, this one runs for y hours, x plus y has to be 60. And then if we get the y by itself, y is 60 minus x. Okay, so now the important equation is the one that says to get these 5,850 gallons into the tank, we've got to take 150 gallons per hour times x hours and add it to 80 gallons per hour times y hours. And then we know that y is 60 minus x. Okay, so there's our setup. This is the equation that's going to give us a solution. Let's see, so that'll be 4,800 minus 80x plus 150x equals 5,850. These two together are going to make 70x, positive 70x. Subtract the 4,800 on both sides, and this will be 1,050 equals 70x, and I think that should give us 15. 15 hours on the faster one, and then, what is it, 45 hours? 60 minus 15, so 45 hours on the 80 gallons per hour one. All right, let's see. We've got one more even problem here, problem 6. So let's go ahead and do that one, and then that'll be it for this assignment. All right, problem 6. Our water tank is 2,500 gallons. And we've got one spigot at 75 gallons per hour. And the other one, 100 gallons per hour. Okay, and the sum of the running times is 30 hours. So we know that X and Y have to add up to give us 30 hours. I'll call this one X hours and this one Y hours. And then we'll get the Y by itself. Y is 30 minus X. So this will say 100 gallons per hour times Y hours plus 75 gallons per hour times X hours is going to fill this 2,500 gallon tank. And then we'll replace the Y with the 30 minus X, or you can just start out by calling this 30 minus X and putting that in your equation. And this is where our answer is going to come from. So 3,000 minus 100x plus 75x equals 2,500. So this will be a negative 25x. And then when I subtract the 3,000 on both sides, I'll get negative 500. Okay? And then divide on both sides by negative 25. And so X is going to be 20. And that means Y is going to be 10. Okay, so that's it for this assignment. Okay, you'll have problems very much like these when it comes time for the final exam. So I encourage you to work through these. And if you get stuck, ask questions. You do have access to the online math lab as well as the Zoom conferences that I'm doing once a week. You can email me with your questions. Whatever it is, don't just push it aside. Okay? I encourage you to work through this. I think that these are interesting problems, and I think that it is valuable to understand them. So